One, you test at what level, 5%. Two, whether there is a difference, significant difference between the sample mean and the population mean. This question is dealing with what we call testing the population mean and small sample. Testing the population mean and the sample size here is small sample. Why small sample? Any sample less than 30 is known as small sample, and we normally use the distribution here as T distribution. Before we make any computation, the testing hypothesis requires that we formulate the hypothesis, the two of them, and because there's a statement here, you test whether there's a difference between the sample mean and the population mean. One, we are given the population mean of the lifetime of the electric bulbs as 4,000 hours. So the first step is to formulate the hypothesis. So this is what we do. Question 3a. The hypothesis are first, the null population mean is 4,000. The next, H1 or HA, since we are not told the direction of the alternative, we put this one not equals to 4,000. Then what do we have? The test statistic is T equals X bar minus mu all over S over root of N, where S is the root of now the X minus X bar all over N minus 1. This is T distribution with N minus 1 degrees of freedom. So the computation for this part will have to use it from the table, and this is my computation worksheet. I have X, which is the lifespan of the bulb. Then I can have X minus X bar. Then this part, X minus X bar squared. I have them like that. The first one is 4,400, followed by 4,800, followed by 3,700, 3,900, 5,500, 4,000, 3,700, 4,100, 4,000 alone, 5,400, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are 10. Down here, I must have my sum of X. I use my calculator to get their value when I add them. So this one gives me 4,043, 500. So that is the value for that. So from here, I can get X bar as the sum of X all over N. N is the sample size, they are 10, which is 43, 500 over 10. That should give me 4,350. 4,350. So I get the difference of every value of X and also the mean. This one I'll get, then square the results. So what do I get? 4400 minus 4350. I get 50 here. 4400 minus 4350. That is 50. Then I get 4800 minus 4350. 4800 minus 4350. I get 450. 3700 minus 4350, negative 650. 3900 minus 4350, negative 450. 5500 minus 4350, I get 1150. 4000 minus 4350, I get negative 350. 37 again, negative 650. That is 3700 minus 350. Then 4100 minus 4350, I get negative 250. 4000 here, I get negative 350. 5400 minus 4350, I get 1050. The next, we don't add this one because the sum of deviation from the mean is always 0. Therefore, when we are adding the second column, it will not give us any impact. The value will be 0. Therefore, we go the last column where we have the squares. This will give us 2500. For 50 squared, I get 202. 500. 650 squared, the negative becomes positive. 422. 500. We get 202. 500. 1150 squared, get 1322. 500. 350 squared, 122. 500. 650. 422. 500. 250 squared is 625. 62. 500. 350. 122. 122. 500. Then 1050 squared is 1,102,500. Then I add these values. So I'll get here plus 122,500 plus 62,500 plus 422,500 plus 122,500 plus 1,322,500 plus 202,500 plus 422,500 plus 202,500 plus 2500 give me 3,985,000. 85,000. So what do I get here? This is that. So S is going to be root of 3,985,000 all over n minus 10 minus 2 minus 1, which is divided by 9. 427,000, then the square root, 6. The other one becomes 665.4. So S is 5.4. And therefore, I have to get the test statistic. Test statistic here is T equals what we have there. The mean is 4350 minus population mean, which was 4,000. Then all over 66.5 all over root of 10. That should give us a value 4350 minus 4,000, 350 all over 665.4. That's now times root of 10. Divided by 665.4 times root of 10, 1.663. That is the value of test statistic. Now, what do we do? For us to make any judgment, we have to get what the table says, at what level of significance. H alternative is mu not equal that, which means it's either less or more. Therefore, we have what we call two-tailed test. So this is what we are going to do, two-tailed test. So from T tables, T alpha is 0.05. So T of 0.025. I have to read it from, because the half of it, from my normal, from my T tables. And first of all, degrees of freedom is n minus 1, which is 10 minus 1, that is 9. So when I have to read this one at 9 equals, so I put half alpha, degrees of freedom of that one. I read off from my normal T tables to find what is the value. So it gives me 2.262. Therefore, the test statistic compared to T table value, the test statistic is less, and therefore, if the test statistic is less, what do we say? We don't reject this one, and therefore we say there's no significance. So we are saying the test statistic, and that is what is expected for that question for you to earn all the 8 marks.